Hi, this is Marty Bradley. Welcome to the overview of behavior-driven development. In this discussion, we'll go over what behavior-driven development is, what are some of the benefits, and then also who in the team actually participates. We'll go through the rhythm of BDD and explain how it fits into the full life cycle of the Agile process. And finally, we'll talk about the Gherkin language, which is what really gives you the living requirements in the domain-specific language. Behavior-driven development is a disciplined technique for building software in which the product owner, a programmer, and a tester all collaborate on the system behavior. A lot of times we used to call this acceptance criteria. You'll also hear a term called Three Amigos meeting or the power of three. Again, this is a meeting when you write the behaviors of the system. They should really be taken care of with at least three people in the room. It should be the product owner or a subject matter expert along with a programmer and a tester, because you get different views on the user story and it helps clarify things as it goes into the sprint. A lot of other names have been used: acceptance test driven development, specification by example. These are all great terms, but just like with test driven development, one of the things that we want to get away from is the concept that this is only a QA type of function. This is really a whole team function that needs to be centered around the implementation of the behavior. So the product owner really needs to be involved from the beginning. QA needs to be looking at it from the beginning, and development should be developing off of this behavior and automating their tests with it.
Alive! It's alive! It's alive!
See that living specifications can be very exciting. So when you guys go to build your monster application, and by the way, anybody that didn't know I was going to follow that up with a monster joke, you should probably turn the video off right now. So what we're going to do is we're going to talk about the Gherkin language, but it follows the given when then format. This is what you'll be doing in your Three Amigos meeting, is basically detailing out these scenarios. These scenarios are then fed into a tool called Cucumber, which provides you the ability to do automated testing. And as you can see, the specifications will be kept up to date, because anytime there's a change to the specification, the test will fail. You modify the code until the test passes, and then everything continues into that life cycle. So if you're familiar with test-driven development, this life cycle should seem very familiar. It follows the same red-green refactor life cycle as test-driven development, with a couple of key differences. In behavior-driven development, you test from the outside in. And what that means is that instead of writing a test for a specific piece of technology, a functionality, testing an algorithm, that test will fail because the algorithm doesn't exist. In behavior-driven development, you're going to create your executable specification, and the test will fail because the feature hasn't been developed yet. What this does is it helps the team build software thinking about the customer, basically focused on the feature that they're trying to deliver. Here's an example from the outside looking in as opposed to the inside out. If you look to the right, this is really from the inside out. It's very hard to share with the product owner. As you can see, without even understanding what it is, even if you're a developer, you look at this and you see it looks complicated, or it's not very clear, right? If you look to the left, this is a Gherkin language. This is written in something that's readable. A product owner can read it, tester can read it, developer can understand it. So it's very easy to collaborate on the text to the left as opposed to the text on the right. Okay, so let's start to talk about what we mean when we talk about defining a requirement. If you look at this first line, it seems pretty clear. Customers should be prevented from entering invalid credit card information. That seems pretty obvious. And as a developer, we start thinking about all kinds of things, the expiration date, the CCV code on the back, and other type of things that could happen. Now, if you look at the second definition, it gets into a little bit more detail, and it's actually very clear that really what they want is they have a very common problem where people have a hard time typing in the 16 digits. This requirement is very focused on just dealing with the 16-digit issue and giving a nice descriptive response to the end user. Again, the second one, a lot more clear, and it's very unambiguous. Behavior-driven development follows a red-green refactor cycle. The system behavior is defined by a group of scenarios that let you quickly add a slice of functionality to help you learn about the system. As the product owner learns about the system, or the tester, or the programmer, they have input to the scenarios. They can either modify the scenario or add new scenarios. As we add these new scenarios or make changes, the test will fail, turning the test red. We'll make changes, turn to green, then we'll refactor the code to tighten it up or make any architectural changes that are necessary. The safety net is provided by automating these functional tests. And then finally, the tests really act as the first user of the system. Since it's feature driven, it's based on what the user is asking for, so the tests are very centered around the user and what the user wants, and it makes the code a lot more reusable. Some of the benefits that we see from behavior-driven development are increased usability. The system functionality is more deliberate. It's being driven from the scenarios, and the developer is constantly placed in the paradigm of a user of the system. This user results in fewer defects. The other thing is that, as we mentioned before, the specifications are living. Through the automated tests and the behavior of the system, as you change the scenarios, they fail. You change the system, and it's constantly in sync with what the documentation is saying. To continue on with the benefits of BDD, you generally see a higher quality of code because testable code tends to follow a better design pattern. It's more modular, flexible, obviously more understandable because not only do you have the system, but you have the system under test and the test scenarios that you can read through to build examples. The second thing is that because you're doing smaller incremental slices and you're developing tests as you go, you build confidence in your ability to not only change the system but to understand the system. Additionally, as you move forward, the tests in general also give you some sort of regression capability. And finally, behavior-driven development helps for faster delivery of your code. The tests allow new features to be added much more easily without breaking existing ones. And then misunderstanding of requirements appears far earlier in the development cycle. Obviously, this makes it easier to debug and to move forward with the system. So in behavior-driven development, how exactly do we develop these living specifications? As I mentioned before, the Gherkin language is consumed by a tool called Cucumber. Cucumber in its native form was written in Ruby, but it has two sister applications which are basically just rewrites of the core code, one written in Java, Cucumber JVM, and another called SpecFlow, which is a .NET language. They all use the same Gherkin parser and can consume the Gherkin text file that we've seen and that we'll see examples of in the next couple of slides. So Gherkin basically defines the scenarios in a given when-then format, and it creates a structure so that the behaviors can then be automated. Gherkin uses a lightweight structure for documenting the examples of the behavior. That way you can collaborate with the stakeholders, with the product owners, and non-technical people for the features. Since Gherkin only has a very few keywords, the team can basically build their own DSL, or domain-specific language. Really all this refers to is that the business will use business terms to describe the system, and then the developers will then create objects inside the system that are actually the same names as the objects that exist in the real world. It helps to facilitate the communication between development and the business. And finally, one of the things Gherkin does to help you organize your tests is it allows you to tag your features and your scenarios. So that, for example, if you're doing a continuous development or a continuous integration environment and you need really fast builds, you could annotate things with @fast and then only run those when you're doing your incremental builds throughout the day, and then possibly have some tests that run a little bit longer and you run them all the time at night. Alright, so let's go through a basic example of using Gherkin. I'm going to take 3 slides to do this, and we're going to go through a good scenario, better, and then best using the same example. This is just a simple scenario where somebody wants to be able to check their inbox and see that they actually received an email that was sent to them. Now you can see in the Gherkin we have the given, when, then keywords, and the rest of this is really just domain-specific language. So it's a user and a password, but one of the things you can already see from here is that there's a lot of detail in this scenario, and it makes it kind of hard to read. Okay, so let's make this example just a little bit better. Let's get rid of some of the incidental details. In this case, it's the password. And a lot of times we don't want the password open to the public anyway. So we take the password off and you look at the text now and it's actually already a little bit clearer. But there's one more thing that we can do to make this even more readable. Okay, let's do one last thing to this scenario to clean it up, make it a lot more maintainable and actually reusable across multiple users. In this case, we know that what we're trying to do is check an inbox. It should really pertain to anybody's inbox, not just Dave's. So if Sue sends an email to anybody, when they check their inbox, they should see one email. The scenario is now very clear. It's easy to read, it's easy to maintain, and it can grow with the system. And of course, as always, the product owner is going to take complete credit for this. Okay, so let's summarize what we've just learned. So first of all, the product owner is going to create a user story. We're going to take this user story, and at this point, we can actually do some planning. So we can story point it and get it ready for a grooming session. So now that we have the user story, we can sit down and do a grooming session with the product owner, a developer, and a tester, and we could create the given when then criteria, along with some sample data. What this does is starts to facilitate the acceptance criteria, starts to build our test strategy and the data management for what we're going to do. Now we can go into planning. We're going to actually break this user story down, and the developer is going to use Cucumber to drive the development. So basically, a user story goes through 3 iterations. The very first one is the product owner creates a user story with bolded scenarios. The second is that we sit down and we do a 3 amigos meeting with a product owner, developer, and tester, and we detail out the given when then criteria, which is the acceptance criteria. And then the third phase is the developer actually developing the story using Cucumber. So in conclusion, behavior-driven development is a disciplined technique for building software in which a product owner, a programmer, and a tester collaborate on building system behavior.